Good day, ladies and gentlemen. I'm Dr. Hern. This is a project proposal presentation under research design, and my title is Prediction of Health Expenditure in Malaysia using Machine Learning. So this course is taught by Associate Professor Dr. Muhammad Shaizan. So I will start with the research introduction. So for the problem background, in Malaysia, total health expenditure has been growing from 35 billion to 75 billion across these 10 years, and the growing medical costs present major challenge for the healthcare sectors. Health expenditure is defined as all the money spent on health goods and service, and the health financing in Malaysia is largely funded by public funding, like 52% of it, and followed by private source of financing, like from household and insurance, accounting for another 47%. So it can be seen that in budget 2025, Malaysia government has allocated 45 billions in the healthcare, which is second highest after education. And with the inflation in medication price, medical expenses, and aging population in Malaysia, it is anticipated that healthcare expenditure will continue to grow, and it poses a great challenge from the government and people. Coming to the problem statements, determinants of healthcare expenditure are complex and varies depending on the prediction model. So growing health expenditure in Malaysia is actually a significant challenge from government, and machine learning algorithms performs differently depending on the context of the available data sets. So it contributes to our research question: what are the key determinants of health expenditure that contribute to accurate prediction in machine learning algorithms, and what are the predicted health expenditure of Malaysia from 2026 to 2035 using machine learning algorithm, and how do different machine learning models perform, which one demonstrate the highest accuracy. So for the aim and objective, the aim of this study is to predict health expenditure in Malaysia using machine learning techniques to provide insight for the health financing and policy making. So the research objective is to identify the key determinants, to apply random forest and arima for predicting the healthcare expenditure, and to evaluate and compare the performance metrics between the model to choose the model with the highest accuracy in forecasting the healthcare expenditure in Malaysia. So the source of the data will be from KKM, World Health Organization, and World Bank. So the scope of data will be data related to health economics. They are open source, and no individual data will be collected in this study. The expected research contribution is that this study is able to provide insight for policymakers in the country in planning health expenditure and ensure long-term sustainability of health financing. From a research review, we found that health expenditure can be represented by total health expenditure, government health expenditure, and also the household out-of-pocket health expenditure. So from the systematic review, it shows that publications related to health economics are sparse and inadequate to meet the stakeholder and policymaker needs. Despite that we are saying that the health expenditure is keep going up, the public spending on health in Malaysia remains lower when compared to the average 6.3% GDP for other countries. So the low public health spending may cause like chronic understaffing, high workload, and critical infrastructure shortage. So at the same time, the rising out-of-pocket payments and increased pharmaceutical costs are creating a risk for the healthcare system. So by using the predictive analytics, we can actually reduce the healthcare costs, improve the efficacy in the healthcare system, and improve patient outcomes. From the literature review, it can be seen that there are several research gaps to be filled. First is the limited academic research on Malaysia healthcare expenditure prediction model despite needs. Also, the health expenditure is affected by multiple factors, and traditional models struggle to capture a complex and non-linear relationship. So different determinants or features of the total health expenditure is used from the study from different countries, and there are no general consensus between study on which one is the best. So the existing model, there are a few models that will be used, like ETS, exponential smoothing model, regression model, gray model, ARIMA model, and other machine learning like random forest, support vector regression, and also artificial neural network. So we'll compare the strength and weakness of models from the literature. It can be seen that gray model has works with a small amount of data, but it has a poor long-term forecasting. ETS give more weights to the recent outcomes than the past observation, but there are limited cooperation of external factors. ARIMA model have a better explainability and flexibility, and it has a better performance for small data set. However, it is limited by its univariate modeling. Artificial neural networks able to manage large and complex data, but it requires a large amount of training data, and requires the computational resource and time. Random forest also have the same limitation where it requires computation resource and time, but it is less affected by missing values, lower risk of overfitting and bias, and lower overall variance. So the determinants of health expenditure proposed in or the literature actually varies, but we can see the similarity between the studies that GDP, life expectancy at birth, number of hospital, and number of the physician is actually used in most study. Population size, age population above 65, and infant mortality rate are usually used as well. This is a research framework, so we will start with the problem formulation, continue by the data collection, proceeding with the data preprocessing, exploratory data analysis, modeling, and result evaluations. Coming to the data collection, we scrap the data from the MHNA reports from the Ministry of Health, and also initial indicators is downloaded from the World Health Organization and World Developed indicators from World Bank. So the pre-processing is we explore the data first, and then data cleaning is done to correct the data types, identify removing errors, and fixing the formats. Also, we transform the data into the suitable structure, fixing the header, dropping unused row and columns, and setting the year yes index. So data cleaning is extremely important to make sure the data is suitable for the next steps, like the machine learning. So data integration is done where the data set is actually combined into one unified data set. So feature engineering is done as well by creating new feature from the existing data set. Like for the out-of-pocket health expenditure, we actually do some calculation to get the actual value. So coming to the exploratory data analysis, descriptive analysis of health expenditure will be done using the matplotlib and seaborn library. We'll visualize all the features and also plot a correlation heat map for analyzing the result. So correlation heat map is just code is shown here. So two algorithms is selected in our study. ARIMA and random forest are chosen based on all the previous studies. ARIMA is done using univariate, which is the lag value of ARIMA, while random forest can use more variable compared to ARIMA. So random forest is a supervised machine learning method. It ensembles multiple decision trees to achieve a higher forecasting accuracy. It works for the regression problem as well. So random forest is done by importing from scikit-learn in Python. So we split the data into trend and test set, fitting it into the model, and also predict the result. So ARIMA is a time series predicting model that can be broken down into three parts: autoregressive, integrated, and moving average. The error parts of model represent a combination of past data points to forecast future values, and the integrated part turns the time series stationary by performing the differencing to eliminate trends and seasonality. The moving average part focuses on the relationship between observation and residual errors. So it's combined with the ARR to improve attention for recent incident than the pure ARR process. For RIMA model, we import the package from the stats model and we conduct an ADF test to test the stationarity. Then we plot a SCF plot and PSCF plot to determine the order of P and Q, which is the AR part and MA part. Trend test split is done as random forest, and we fit the time series data to the RIMA and forecast the result. So the evaluation metrics, three metrics are used here: mean absolute error, root mean square error, and also coefficient of determination. Finding is that this is our pre-processed data set. The line chart shows that there's a gradual increase in health expenditure over 23 years, and strong positive trends is observed from the line chart. For the health expenditure in Malaysia, it is also the same. The health expenditure is a steady growth. Expect that in between 2019 and 2022, there is a fluctuation due to COVID-19. Correlation heat map shows that there are a strong positive correlation for GDP, population in thousands, total population age 65 years old, and number of physicians per 1,000 people against the three health expenditure. Moderate positive correlation can be found for the life expectancy at birth, and there's a strong negative correlation for population growth. Number of hospital beds and infant mortality rate weekly correlate with health expenditure. So these two columns are actually not selected as a feature for machine learning models. used for the random forest. This is the initial finding for the random forest. You can see that the prediction actually doesn't work very well on the charts, and the mean absolute error is very high. RMSE is very high as well. So coming to the ARIMA, it shows that from the ADF test, differencing has been done. So we difference the time series data once. SCF and PSCF show that the cutoff point is at 0, so P and Q are set as 0 for ARIMA model. ARIMA model actually performs great when used for the total health expenditure. It lies pretty close to the actual values, with the R score is 0.8, indicating a good fit. And the RMSE and MAE is pretty low, around 2 billions. So from the initial findings, it can be concluded that ARIMA outperformed random forest in forecasting Malaysia total health expenditure, and random forest actually requires more tuning and more data for better result. So from the conclusion, RIMA actually outperformed random forest in forecasting Malaysia total health expenditure. Random forest performance is poor due to the absence of lag value used as features, insufficient training data, and lack of parameter tuning. So ARIMA works better for a small data set, and random forest require more data and further optimization. For the master project, hyperparameter tuning and validation will be prioritized to improve the accuracy and reliability of the models. For future works, the methodology of this study can be extended to Asian countries with similar health economic structure, and smaller component of health experiences can be applied using the same methodology as well. We can also look at the individual healthcare cost prediction by using patient factors like medical condition and current medication. Thank you for your time. Thank you very much.